In this lesson, we're going to solve equations by elimination. To do that, we have 5 steps outlined, including checking your answer at the end. Basically, it involves multiplying one or both equations by a constant, adding the equations together, solve the equation that results, because then we'll only have one variable, then substitute to find the second variable. So if we work through some examples then, we see here we have 3x minus 2y equals 4, and x plus 3y equals 2. Because there's a 1 in front of the x, it tends to be easier to work with that, so that's what we'll focus on. If we want to cancel 3 x's by adding it to an x, well, we need minus 3 of these x's. So what we're going to do is we're going to keep equation 1 the same, and we're going to multiply all of equation 2 by minus 3. That gives us minus 3x minus 9y equals negative 6. Remember, each term needs to get multiplied by negative 3. And what happens then, when we add these together, you notice that the 3x plus negative 3x, well, those cancel, leaving 0x if we want, but we don't even need to write that. Negative 2y plus negative 9y is negative 11y. And 4 plus negative 6 is negative 2. And this we can solve if we divide both sides by minus 11. We get y equals 2 over 11. And so there's the answer for y. To solve for x then, we just put it back into one of our original equations. Doesn't matter which one we pick. The second, though, has a coefficient of x equal to 1, so that's easier to work with. So we'll say x plus 3 times 2 over 11 equals 2. X plus 6 over 11 equals 2. So x equals 2 minus 6 over 11. And you can do that on your calculator or check it by getting a common denominator. Either way, the answer is 18 over 11. So there's your x, there's your y, and if you plug x and y into each of the equations above, you'll find that it works in both equations, so we have the correct solution. So that's solving by elimination. We'll do example 5 as well then, and you notice in example 5 we don't have all the terms lined up like we did in the one above. So the first thing we're going to do is actually rearrange this so that we get them looking the same. So we'll take equation 1 and we'll work over here to give us lots of space. So equation 1 can be written as 4x minus 2y equals 3. Equation 2 can be written as 4x minus y equals 2. And all we did is arrange it so the x's are first, then the y's, then the equal, then the constants. Now, we want to eliminate a term. So in this case, let's eliminate the y. We have minus 2y's up top. We have minus y on bottom. So what we're going to do is we're going to take the bottom equation and we're going to multiply it by negative 2. We have negative 2 on top. In order to add, we need the opposite coefficient in the bottom. So negative and negative is going to give us positive, and the 2 means they'll be equal. So what we end up with is 4x minus 2y on top equals 3. And on the bottom we get negative 4x plus 2y equals negative 4. So when we add these together, 4x plus negative 4x is 0x. Negative 2y plus 2y is 0y. And that equals 3 plus negative 4, which is minus 1. So we end up with 0 equals minus 1. Well, that doesn't make any sense. That's not true. That's because for this example, there is no solution. These lines would be parallel lines if we were to solve for y and graph them, so that's why there's no solution here. And that'll always be the case if you get something that's not true once we solve, provided we've solved and done the steps correctly. So that's the 2 examples on elimination. Make sure you do more practice. In the next lesson, we're going to go ahead and start talking about determinants, which is another way that we can solve these systems of equations. As always, if you're having problems or you don't understand something, email me, comment on the video, or come see me and we'll get you sorted out. We'll see you in the next lesson.